think it's time to start up, so thanks for coming for this talk. The basic idea of this talk is to bring awareness of a topic that bothers me for quite a few years. But let me introduce it to you and see how it goes. So my name is Rachid. I'm self-employed. Basically, I do a lot of stuff around cloud architecture with my clients, and I travel around in different, let's say, community, Azure MVP, CNCF ambassador that was announced in KubeCon last month, Docker Captains, and Snyk ambassador, which is one of the reasons I'm here. I'm here today. You can find me almost everywhere on the internet, LinkedIn, Twitter, whatever. What I do, a lot of stuff. So this is what I do with my clients at the middle, and at the bottom, this is what I do in the community side. I'm heavily invested in actually a lot of communities, either as a speaker or in the CFP committee or as the organizer. So I was one of the organizers of the K-City France that was held back in March. So again, if you want to join us for an event or you want to have me speaking at your event, just please reach out to me and see how we can make it work. Let's dig in. So what we have here is a global systems that helps developers to build secure software. This is what we call SSDLC, Secure Software Development Lifecycle. Basically, the idea is how we can make sure that once an application has been built and ready to go in production, it is the safest as possible. And I really mean the safest. Again, we'll see that later on. We'll be focused especially in these red areas because this is a security talk, obviously. So detecting secrets, SBOM, which has quite a momentum, manifest scanning. We'll see how these tools can help us in making sure that our platform follows CIS benchmarks, that we don't have vulnerabilities, just to make sure that, again, when we push our application in production, we have, let's say, this green light that says, go on, it's fine. Topic today is about vulnerability scanners, and this tool has quite a few features. So obviously, find vulnerabilities. This is a fact. Some of them also offers CIS compliance, especially in the Kubernetes world, meaning that they will help you to make sure that your Kubernetes clusters follows all the best practices in security area, so RBAC, privileges, so on and so forth. When you move a little bit further on, some can help you into finding tokens and passwords that you may have left, perhaps by mistakes, in your sources, or even help you in finding some misconfigurations, RBAC that are not that well made, or basically a cluster that just has been built out of the blue, put out in production without making sure that, again, all the best practices have followed. So these vulnerability scanners had a lot of features, and the one will be focused in this talk is obviously how these tools finds vulnerabilities. The famous one, so I use Tree because it's one of the famous, but again, there's a lot of other tools that does the same behavior. So this is how it works basically. It works in two different modes. Standalone, this is what we have in our CI/CD pipeline, or you can either deploy it in your Kubernetes platform as an operator. This is another topic that I will discuss later on. And on top of this, two different deployment methods. There has a lot of features that this tool has. So finding vulnerabilities again, look at your images, systems, configurations, so on and so forth. How it works. So this is a graph that explains how the operator works. So there's a server and client mechanism. So basically we have the client on the left, the server on the right. And when you want to make sure that your images or your platform is secure, you just trigger the server, and this server just does its magic somewhere just to make sure that you have all the information that you were looking for. The basic output would be something that would be close to this, what we have here. So I looked at the critical, but obviously there are some others. And it helps you in finding those vulnerabilities, what they are. You have a link to say what is this vulnerability about, the package or the library that is vulnerable, what is the fix if it exists, so on and so forth. So at this point, this is what most vulnerability scanners, let's say, works. And it should be fine. It should be fine also because when I work to some of my clients, they just say, hey, you know what? We have this SLDLC stuff. We build this highly secure, modern, and dynamic pipelines. We make sure that we have all the tools, that we have this green light, and we are fine, and we are ready to go in productions. At least that's what we could think of this mechanism. Obviously, there's a catch. Quick question. At this point, does anyone see any catch somewhere in what I have just exposed? Just raise your hand, just to 1, 2, 3, 4. Okay, should be fine. The first catch is those vulnerability scanners gives you a lot of information, like really a lot of information, and the main issue here is how your development team can handle all of them. Which of these vulnerabilities is applicable in your application? Should you really care about them? Or should you not? Are you able to fix them? Because probably at some point, some of those vulnerabilities can't be fixed at the time they have been discovered. This is one of the issues that I often see with my clients is, so they have this report that says, hey, you know what? We are in jeopardy. We have like 200 and whatever vulnerabilities. What else? I don't know. I don't know your application. I haven't built it. I don't know what's your business case. So let's dig into each and of them and see if we can fix them or if we just simply have to ditch them. And the first catch here is it takes really a lot of time. And it takes a lot of time, especially on the development team, because it's not really to the development teams to have, how would I say, most of their day-to-day job to be focused in this. Of course, security is important when you build software, but you should not, how could I say, have someone spends days only to look at those vulnerabilities and say in the end of the day, okay, so I just crawled all of them, the 200 and whatever, and we just have to fix 2. Another point is, so friends at Snake published this report that you have below these pictures, and this report has a very interesting information. It says that in most cases, it takes kind of 3 months to fix a known and found vulnerability. 3 months. So it means that once your shiny new vulnerability scanner says, hey, you have this vulnerability, it could take you 3 months to fix it. What happens in the 3 months is, depending on what the application is doing and what's your business, and 3 months is obviously a lot of time. And it can happen a lot of things in 3 months. I mean, it's easier nowadays, sadly, and it's getting faster and faster to see someone who breaks platforms in a matter of hours, not weeks, not days, hours. 3 months. I think I'm missing something. Or at least that's what I thought when I created this talk. This was about 3 months. Okay. Who spends 3 months in fixing vulnerabilities? Because again, fixing means that this vulnerability has been found, put somewhere in whatever the system, the backlog, or whatever, and someone has taken the responsibility to fix it. And once someone says, hey, I will fix it, it then could take 3 months to fix it. Let's get back to the SSDLC stuff. So this is what we have, and again, this is where you can find Trivy, Sneak Scan, Docker Scout, whatever the tool. Almost everywhere. So again, it should be fine. It's not, but when you look at this graph, you should think that it should be fine. I said fixing means knowing. To fix something, you should know that you have something to fix. If you look at the bubble over there, it says GitHub TrivyDB. So again, this is about Trivy, but all the vulnerability scanners that you can find works the same way. They download some kind of database, files, whatever, ingest it, crawl your applications and say, oh, what I have in my database says that your applications is vulnerability at this and this and this and this and this. "12 years. 12 years until this vulnerability, Polkit, as far as I remember, has been discovered. It meant that this vulnerability lived in the kernel, in the Linux kernel, for 12 years. Again, fixing means knowing. If you don't know about this, there's nobody who would fix it. And nobody will say, hey, you have this issue. This lives for 12 years. So when I worked to build this topic, I found this very interesting paper, and that has been shown on Usenext August last year, as far as I remember. Basically, this is a research, and the research was focused on how long a vulnerability really lives, meaning how long since this vulnerability has been injected, let's say it that way, until it has been found, and then there's a fix, and then this fix is implemented. Basically said, this is what we have. Vulnerability has been introduced, found, disclosed, and a fix is available. I highly suggest you to look at this paper. It's really, really interesting. So this is a heuristic research, but it's really interesting to look at how they work on this topic. What are the key values that they were looking for? What are the methods that they used to gather this information? In the end, we have something like this. So they just took Chromium, PHP, and this is an average. So these are days. Just let's do the math. Just take 1 second and do the math. This is what I thought when I look at this paper. I was like, seriously, it can't be true. Because when you do the math, here's what you found. 4 years. Each vulnerability that has been discovered at a time could have lived somewhere in the software for an average of 4 years. We're not anymore into this 3 months or 3 days or whatever, 4 years. If you look at what happened back in this last year or in 2021 when they had this Elasticsearch platform that has been found and completely wiped out and so on and so forth because nobody has taken care about securing their access and so on and so forth, 4 years. The main reason for this So there are different reasons for this, to have this, how could I say, this value, high value. The first point is human builds software. And human, by design, makes mistakes. Even ChatGPT makes mistakes. So we do make mistakes, and at some point, we can't how could I say, add new feature to a software and think about, oh, I built it correctly. I tried to take care of every security aspect I could, but we're human, so it could fail. And this is where it hurts, because we're human, we make mistakes, we try to find those vulnerabilities, and we try to leverage tools that should help us finding these vulnerabilities. Again, these tools use databases that humans built. Just look around. It's not that, let's say, funny at this point. And truth to be told, when I really worked on this topic, I was like, okay, we have problems. But it could get worse. It could get really worse. Let's say that, let's ask us 3 questions. Just 3 simple questions. Does this tool knows about our application use case? Does this tool knows how our users should connect to it? How your application is connected to third-party systems? What's your business model? How you should use this application, if it's an e-commerce platform or, I don't know, video games that you play on your browser, and so on and so forth. Obviously, the answer is no. This tool don't know anything aside of your application code itself and this shiny new database that they use. They don't know anything about your application. And this is where at some point I try to, how could I say, raise awareness with my clients to say, hey, you know what, these tools just don't know anything about what you're really doing. Again, the same as ChatGPT. It don't know what you're asking, and it don't know what he's answering. It's just math and magic somewhere that does this magic calculation to say, oh, I think that this answer could be the best that I could give you. It doesn't understand what you says, and he doesn't either understand what he answers. And it's the same for those applications. So just to wrap up at this point, we have those vulnerability scanners that help us, definitely. What I mean by that, if those tools doesn't exist, it could really be worse. So this tool helps, definitely. And there's a lot of mechanisms that exist to ingest information into these databases. So we have to use them. They help us in our day-to-day job. They help us fixing vulnerabilities. They help us find them. Again, it's just a matter of which vulnerability we should fix at first and then see at the others. But there might be blind spots. And again, to know that they're blind spots, you should know that they exist. Again, fixing means knowing. You can't fix what you don't know about. And what I, let's say, again, try to raise with my clients is to take 2 main, let's say, known blind spots, just to, again, raise their awareness about this bad behavior at some point. Actually, there's 2 or even more. Again, fixing means knowing. So if they don't know about a vulnerability, if this vulnerability hasn't been disclosed, if nobody has written what this vulnerability is about and what it, how it can somehow break your application or break your platform, no way to fix it. And as I said before, this tools doesn't know anything about your app, doesn't know anything about you, about how you built your app, about how this app should work, and so on and so forth. So how to fix? This is the question that I had at some point. So one of my clients just reached out and say, okay, I got it. You might be right, but what can I do? I mean, you just told us that we have to use those tools. Okay, so we use those tools. We add them in our CI/CD pipeline. So look at the graph that we just showed you. We just followed your best practices, and now you're just saying that we have to fix something that we don't know about. Back in the days, I was used to push those three tools, SLInux, AppArmor, and SecComp. Basically, the idea was, let's try to put as much security as possible in the platform and not in the app. Meaning, you have put enough energy in making your app as secure as possible. Now let's see, where we have some blind spot and what we can fix at some point. If you, anybody, is there anyone who doesn't really know about those tools? Like just discovering them? Okay. So these tools works close to the kernel. SLInux and AppArmor works just in front of the kernel. They have different mechanisms that helps to filter what an application binary tries to access or modify in the system, like opening file, writing information into the files, opening network connections, and so on and so forth. The main difference between the two is how they have been implemented. SLInux is heavily used, or should be used, in the Red Hat, Fedora, CentOS world. AppArmor is more a Debian, Ubuntu stuff. And basically, they use policies that you build, compile somehow, then this tool loads these policies, and then look at, in real-time manner, it look at everything that happens in the systems to say, okay, allowed, forbidden, allowed, forbidden, allowed. The last one, SecComp, is probably the most complex ones. These ones look at syscalls directly. So pure kernel, let's say, calls, pure kernel system calls. And it's, as this name implies, not that easy to use, but at the same time, it's the most powerful. Meaning, if you really have the grasp on how deeply your application works, what it needs, how it accesses files, how it opens network connections, and so on, this is probably the best solution that you could implement in your system. I said syscalls, so you probably may think that it's not that easy. It's clearly not that easy. Probably the easiest one, or at least that's what I think, is AppArmor in the middle. SLInux use some kind of a context that is not that, let's say, human readable. And SecComp is even worse. I mean, if you don't know anything about syscalls and how they work, just you can't possibly leverage it. There are tools that helps you in building these policies, especially for AppArmor and SecComps. Look at a call tool Bane, B-N-A-B-A-N-E, in the, what's the name again of this repository? Container tools, I guess. And this tools helps you to look at what your application have access to, what it tries to access, and just tries to help you to build this policy for SecComp. This is what my client thought. No way. Way too complex for us. Okay, this is complex. I get it. I can't really help you in building this because if I help you building this and then I leave your company because, as I said, I'm self-employed, then I have to make sure that someone in your team is able to, let's say, follow the rule that I built. So what should we do? And this was one of the concerns not that long ago, truth to be told. So I just, again, thought about this problem differently and look at what could we do to offer the same level of security, kind of, or let's say the closest as possible, without using tools that are too complex or that needs too much energy just to be able to use them. Because again, SecComp is really the hardest. And even AppArmor, if you use Bane, when you look at the policy that it generates, it's really not human readable. So this is what I use today. Those 3 new friends that I have, so I have actually 2, and another one is fairly new. The one on the left is Tetragon. You may have heard a lot about it. In the middle, this is Falco that has been built by Syzygy, and the one that's on the right is something that is called KubeArmor. And basically said, sorry guys if you look at this talk, it tries to use the two without all the complexity to build rules. Basically what AppArmor does is, we all know YAML, because we use YAML every day, so we are experts in YAML. We can write them by heart. So the idea was, if you all know YAML by heart, then how about you leverage YAML to create those policies, and then our tools will translate them into Falco or Tetragon or whatever the solutions. Kind of an abstraction systems, but at the same time, it also offers, well, missing my word, a UI that helps you to look at how it works and helps you to create these rules. They have templates and so on and so forth. 3 of them have the same love, I would say, kind of. And it's this B here. You may have heard a lot about this one. I won't talk about this one. So this B is about eBPF. Basically said, so back in the days when you wanted to have a deep understanding of what's going on in your systems, you have to build driver. Driver is, let's say, connected to the Linux kernel that you're using, its version, and then each time you're doing an upgrade of your systems, you have to rebuild this driver and probably hope that the rebuild will work. And now you have this new driver, you load this driver, and now you can have access to it. To the information. What eBPF does is simplifying all of this. So there's no need for drivers stuff. You're at the closest as possible of the kernel without this hassle, and you have direct access to all this information. You just have to build props, basically, that are not tied to the Linux kernel version that you're using. And using this prop, you can have access to all the information. One word of advice, I'm saying this probably way too many times anyway. There's no priority, or as long as I heard of, there's no priority mechanisms when you use eBPF. What I mean by that is, the more eBPF build tools that you deploy in your platforms, probably could lead to some performance issues. The main reason is all those tools has the same priority, the highest. So they basically gather all the information that they are built for at the same time, or kind of at the same time. So 1 is fine. 2, I won't spend too much time on this, but I did a few tests, and let's say I tried to, I had 1, 2, 3, 4, 5, 6 6 tools that does observability, security, monitoring, blah, 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 around eBPF, and just load some load testing in my client's application. 1 is fine, 2 is fine, 3 should be fine, 4 tries to get a little bit harder, 5 it's getting really, really hard for the application to answer, and 6 the application dies. So just a word of advice, eBPF is really the new thing. It helps a lot. There's a lot of great tools that has been built on top of it. Choose wisely. Don't deploy all the shiny new tools that you hear about that uses eBPF, because at some point it will not help you. It will jeopardize your platform. My friend, my long-time friend, Falco. So now it uses eBPF. Again, at first, it was using this kernel model that has been built. Anyway, basically the idea is how we can gather all the information from the systems using plugins. So containers and a lot of other stuff. So not only the systems, but probably information from GitHub, from a cloud provider, and so on and so forth. Gather them in a central brain, let's say that way, that loads rules, and these rules will then allow you to trigger outside mechanisms, notifications, call some programs, push loads into syslogs or whatever, HTTP, blah, 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 blah. The main idea here is have a simple tools, really simple tools, I'll show you that, without the hassle of SL Linux, AppArmor, SEPCOM, blah, 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 and be able to leverage the information that these tools, how can I say, pushes somewhere to do something. Basically said, how we can at some point leverage automatic remediation. We have detected that this behavior should not be here. Notify development teams, security teams, operation teams, whatever, and then do something. Anyone has a candle? Okay. Demo time. Let's see how it works. So this is my platform. So I use Argo CD way too much, I guess, but I really, really use it. So I have a lot of stuff that has been deployed, Argo Event, Workflow, Falco, so this is the tool. And this one here, named Talon, is what we called a response engine. The goal of this response engine is to get information from Falco and then triggers something. Actions in Kubernetes, send files somewhere, write anything, I don't know, in your database, in GitHub, and blah, 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 that kind of stuff. And there are different ways to use these demos. So either you use Talon, which use rules, not in YAML, kind of, but simple rules, or you can use Argo events that you have here. And basically, this is the event that we have. So when we have a very specific Falco event, it will trigger then a sensor, and this sensor will look at the output of Falco, and depending on the output of Falco, it will trigger something. Here, basically said, delete pods. This is not really what we want in production, but this is just a test. And once the pod has been deleted, obviously Kubernetes restarts a new one, and then, so the idea here, the very simple idea here is how we can pull the plug when we detect something that should not happen, basically said. Falco comes with a UI, kind of, if it works. Yes. So good. So far, so good. And so you have this so critical error, blah, blah, blah stuff. And again, this is rules that the tools has. So it has a bunch of already existing rules, and you can create your own. I will show you that. And this simple UI can help you, well, to see critical. There you go. Basically. So this is all the tests that I've used so far. How it works. So this is the kind of rules that you can create. So this is, let's say, where are you? Terminate shell. So this one I was looking. So this one, basically what it does, it looks at outbound connections in a defined TCP port, and each time that this outbound connection is detected, it sends notification somewhere. Where it sends them, where are you? In my case, it sends it to Talon, and then Talon itself has its rule files that says in here, labelize. How Talon works, you have so Talon has been built by a friend from SysD called Thomas, and Talon has what we call actioners. So basically different actions that has been built to do a lot of things. So you have labelize, you have network policy that doesn't work, so I won't show you this, terminate, and different kind of stuff. So let's see. So this is a cluster. I opened a shell somewhere and do, I don't know, kind of HTTP. Let's do something stupid. We're French, right? So is that fine in the back screen? Okay, good. So call, French website on 8888. Let's see how it works. Obviously, this doesn't work in our case. What happened here is it has been detected by the rule that I built, as you can see here. And my Talon rules said, and this is where the debug gods should help me, it said that it should labelize this by suspicious true. Let's see, suspicious true, yes. So this is the kind of thing that you can use. Let's try something. Let's try now the terminate one. Let's do something again stupid. Activate this one. So the action is Kubernetes terminates. Parameter is grace period, meaning don't wait anymore. If you found this, drop the pod. Continue false means, do you want me to go to the next rules or not? You can build, let's say, piles of rules, and at some point say, if you found this rules, goes to the other, and then stop, or goes to all of them at once. And notifier, I haven't showed you that yet. Slack. Do this. Okay. Argo friend. Let's do it manually because I don't want to wait. Go on. Okay, out of sync. Sync, please. Please. Yes. Okay, so now I have terminate. Let's see how it works. Slack notification, look at here. There we are. This is the actions, Kubernetes labelize, and I have the event, and I have which pod has been labelized as suspicious true. All right. This is where it could fail. I should be honest. And this. And let's do again this stupid thing. Right. Have I said that it could fail?
Yeah.
It failed.
So it should be gone already.
it should definitely be gone already at once. Let's see. Let's see quickly why. So, got it. All right. And what does Talon says? Let's do some live debug just in case. Hey, blah, blah, blah stuff. No, not this one. Let's do it the other one. Oh, yeah, I know. There's a bug in the app. It doesn't load automatically the configuration file when it has been modified. My bad. Okay, should be fine. Please. Okay, go on. Where are we? All right, should be fine. Let's do it again. There we go. Swing, shell, HTTP. One, two, three. Still fails. Told you, good fail. Yeah, there's a bug in Talon, seems like. So I have this notification worked, but okay, let's take a few seconds, and if I can't find why, let's ditch it. Anyway. Pod X-Wing not found. Seriously? It worked. The pod died. Just took a few seconds. Here's how it happens. So this is what has been found. So there's two rules that has been activated. A critical shell has been found, has been spawned. This is one of the rules. And the other one is the one that I built. And it loaded this terminal stuff. And what happens here is it tries to go to terminate, to labelize, and it couldn't find the pod. And obviously the pod has been killed. So it worked. There's a lot of things that you can build on top of Talon, and there are different, response engine that exist. Argo, I told you, Talon. There's plenty of others in the Falco documentation. Tetragon works differently. Tetragon is not about I detected something, I push notification, and then someone else tries to do something. Tetragon allows you to stop the bad behavior directly once it has been detected. Main issue here is it could break the app. So either you choose to let the app die for whatever the purpose, or just let the application push notification to something else that will then do what you have decided to. This is two different ways to see the, to see the workflow. Both works very well. It's just up to you then to decide which one you want to use. I prefer Falco because rules are easier to read and write. I have one of them. So basically you define macros, and when this macros has been defined, you use them in conditions. Well, Tetragon has different ways, but again, up to you to decide which one you want to use. Wrap up. Vulnerability scanners, you should use them. Again, I'm really not saying that you should ditch them. They are very useful in many, many, many ways. Beware of blind spots. I've spoken about two, but there's a lot of different ones. And please, for my safety, if at some point I work with you, leverage this runtime security tools. Low level would be the best, so closest as possible to the kernel, but again, depending on on your business case. And just to finish this wrap up, it's not because you have used those tools, again, that you are completely safe. At some point, we need humans to look at those tools. We need humans to build rules. We need humans to, well, manage this tool. So don't say anytime that, okay, I have vulnerability scanners, I have runtime security tools, I'm fine, let's go to sleep. No way. If I have convinced you on this, then it's time for questions, if you have some. Yep.
The last tools that you've presented can work the other way around?
Oh, there's a mic. Oh, awesome.
Thank you for the presentation. I was wondering if tools that you've presented, the last 3 tools that you've presented, can work the other way around. That you start your production thinking that everything is fine, and you record all the use cases regarding at least network interactions, and the tools write down the rules which would allow those interactions and wrote the script for you, or the YAML for you, and up to a certain point you say, right, so now we cast it in the stone and we disallow everything else. Like a whitelisting thing.
So those tools use predefined rules that helps them detect what's happening in the systems. Let's say that in most cases have already been described in their rules. What those rules misses is your own business case, basically. So you can use them and just let them in the, how could I say, permissive mode. So don't do anything, just detect what's happening and just let me know. Just notify me, perhaps, or push information in the in syslog so that I can get access to what you have detected and then I'll be fine. This is perfectly fine. My advice, yes, is don't try at once and at first to say, okay, I built those tools and now I want to block everything that is not allowed. The rules that I've used for this demo, so the last one, this one, it exists somehow in the default file call rules, but it has been disabled by default. So afterwards, it's up to you to say, okay, this rule has been disabled, but I want to use it and just tweak its configuration for my own use case, or I'll build a new one. But yeah, you can definitely use those tools, let them find everything that's happening in the system, and then look at the output, and then afterwards say, okay, this I want to block, this I will allow, and so on and so forth. Yes. Yep.
I think it's a simple question. So about the security scanner, I was wondering, how do you know if it's just checking direct dependencies or if it's checking like nested dependencies? Does it make sense? So if how you know if the scanner is checking direct dependencies only, or if it's checking also the nested dependencies?
It depends on the scanner that you're using. Most of them, so it depends on the scanner you're using. Let's say that by default, most of them use this CV databases that helps them in finding vulnerabilities. There are others like sneak scans that allows you to go deeper into your code itself and detect pieces of code that shouldn't be here or shouldn't be written that way, and then suggest you some fix at some point. But by default, those tools use CV databases. And then it depends on, how can I say, features that you're looking for. Some goes a little bit deeper, it depends. Most open source tools now use CV databases. And when you look at, let's say, proprietary SaaS, whatever solutions, most of them offer, how can I say, additional functions to look at your code and then have a better overview if this piece of code should be here or if it's behaving correctly. Welcome. We have 1 minute for one question.
Hi, thank you. Thank you for the talk. That's way louder than I thought it would be. I would class myself as an application engineer. From a complete standing start, what would you recommend be the most impactful things you do for, say, a typical like web deployment on Kubernetes? What would be the most impactful place to start looking?
Tough question. What I usually do is, so I start by working with development teams and how can I say, give them tools, insights, informations to have this clear overview of how the application works and if there's any issue with the application itself. And once this has been dealt, I would say that way, then I move to the infrastructure side and say, okay, so we have done this with development teams. Now it's up to us to, let's say, fix what's missing or add what's missing in the system. Most of the time, I shouldn't say that, especially because it has been recorded. Anyway, in most cases, application kind of built correctly with the right tools, but the infrastructure side is most of the time, let's say, left aside. Meaning, I often see Kubernetes clusters out of the box without any security tools built in or configured, and even the API server that is accessible freely from the internet. So at some point, it hurts, yes, but it happens. And time's up. If you have any question, please, well, you will find me in the area. And again, thanks for coming for this talk. Have a good day.